The equation kx squared plus 4x plus 5 minus k is equal to 0, where k is a constant, has two different real solutions for x. I need to show that k satisfies the inequality k squared minus 5k plus 4 is greater than 0. So we've got a quadratic equation here, and I'm told that it has two different real solutions. What that's telling me is the discriminant of this quadratic equation, the b squared minus 4ac, has to be positive. Remember, the discriminant is positive if there is two different real solutions. It's equal to 0 if there is one solution, and it is less than 0 if there's no solutions. So the fact that there is two different real solutions to this quadratic tells me that there is a discriminant of b squared minus 4ac is greater than 0. Right, let's go back to the quadratic and find out what a, b and c are. So a, remember, is the number in front of the x squared. So a, in this case, is k. B is the number in front of the x, which is 4. And c is the constant by itself. So c is 5 minus k. So let's substitute each of those into the discriminant. We've got b squared, so that's 4 squared, minus 4 times a, which is k, times c, which is 5 minus k. Make sure you put that in brackets. Right, 4 squared is 16. 4 times k is 4k. Now let's expand those brackets. So we've got minus 4k times 5 is minus 20k. And then we've also got the minus 4k times the minus k, which is plus 4k squared. I prefer to have the 4k squared at the front, so I'm just going to rewrite this as 4k squared minus 20k plus 16, just swapping those terms around. And then I notice that I can divide everything through by 4. And that is the result that we needed to show. Part B, hence finds the set of possible values of k. So what could k actually be if there's two real solutions to this equation? So let's continue where we left off. Let's continue from the k squared minus 5k plus 4 is greater than 0. And let's solve this quadratic inequality by first factorising so that I can see what the roots are. This allows me to see that there is a root at 4 and a root at 1. Let's draw a little sketch so I can solve this. So there's a root at 1 and a root at 4. So my inequality is going to look something like this. I'm looking for where my inequality is greater than 0, so where it's positive. It's positive over here and here. These are the bits of the graph that are positive. Not this bit down here, that's negative. I don't want the negative bit, I want the positive bits. So all of these values here are where x is greater than 4. We've got like 4.1, 4.2, we've got 5, 6, 7, and so on and so on and so on. This is where k is greater than 4. We're talking about k here, I shouldn't have said x there, k. And all of these values down here are when k is less than 1. So these are the set of values of k. If k is bigger than 4 or less than 1, then that equation at the top here that we started with will have this equation here. If k is greater than 4 or less than 1, then that equation will have two real solutions.